In this problem, I need to find the vertex, focus, and directrix of the parabola and then graph the equation. So I'll start with x squared minus 14x equals 8y minus 73. I'm going to go to the next page and work on that, find the vertex, focus, and directrix, then I'll come back here and graph the equation. So here I have the equation written out, but it's not in standard form. So to get this to be in standard form, what I'm going to do is I'm going to complete the square for x. So I'll have x squared minus 14x plus 49. So I took half of 14, which is 7, and squared it. That's what gave me 49. But what I add to one side of the equation, I have to add to the other side of the equation. So now I have 8y minus 73 plus 49 on the right side of the equation. Now I'll rewrite my perfect square trinomial in factored form, and I have x minus 7 quantity squared equals, now on the right side, I have 8y minus 24. Still not quite in standard form. I have x minus 7 quantity squared on the left, that's fine, but I'm going to factor out the 8, and that gives me 8 times y minus 3. Still not quite in standard form, because I'm going to write this as 4 times 2 times y minus 3. There you go, on the right-hand side. So now I know the value of a. A is 2, and that gives me almost everything I need to know about the parabola, and we can tell that the vertex is at the point where x is equal to 7 and y is equal to 3, because I just look at the h and the k, and it's x minus h is the formula, so 7 is h. So keep in mind, if this is a minus here, then h is going to be a positive. If this were a positive 7, then h would be negative 7. So h is 7 and k is 3, and that's the vertex of this parabola. So we have 7, 3 for the vertex. A gives you the distance from the vertex to the focus. So since this is an x squared equals y situation, then the focus is going to be 2 steps in the either up or down direction, depending on our parabola. In this case, it's up because we have a positive coefficient here. So it's going to be up. Our parabola is going to be facing up. So up is going to be a change in y, and so this is going to be 7, 5. That's where my focus is going to be. And the directrix is going to be 2 steps in the exact opposite direction. And so that's going to be the line y equals 1. So I just took the y value of the vertex, I subtracted 2 from it, that gave me 1, and it's a y value, so the directrix is y equals 1 because the directrix is a line, not a point. So now I've got the vertex, the focus, and the directrix, and I'm ready to graph. Okay, so I've graphed my vertex right here. I've graphed the focus, and I've graphed the line that is the directrix with a dashed line. So now to get a couple of more points on this parabola so that I can sketch it properly, what I'm going to do is I'm going to find the endpoints of the latus rectum. That's a good way to get a couple of more points on the parabola. And so what I'm going to do is I'm going to take the equation that we've come up with in standard form. And so the value of the focus, the y value of the focus is 5. So I'm going to plug that in, and I'm going to see what x values are on the parabola when y is equal to 5. So I have x minus 7 squared equals 4 times 2 times 5 minus 3 in parentheses. So x minus 7 quantity squared. And if I do the arithmetic on the right-hand side, I've got 5 minus 3 is 2 times 4, and that gives me 16. So now I can take the square root of both sides, and I get x minus 7 equals 4, or x minus 7 equals negative 4. And so now, oh, yeah, sorry. So now I need to finish solving for x, and I get x equals 11, or x equals 3. So now I have the points 11 comma 5, that's a point on my parabola, and 3 comma 5 is a point on my parabola. So let's go ahead and graph those. And now I can sketch my parabola, and this is all the accuracy I'm looking for here. I have these latus rectum points, I have the vertex, and so that gives me a nice parabola, and I am done.